are which are very easy to put in Data Connect, and I think we have about 4 or 5 of them. And one of the questions is, I mean, and there's synthetic versions of them. One of the parallel things that the hackathon is doing is following a DAR-a-thon, a data access request. So, but this is the list of tables that we're kind of working with, or one of the lists of tables. So this was researching a number of dbGaP studies, and some of these will show up in what I'm about to show you. So the Top Med Severe Asthma Research Program, the Childhood Asthma Management Program, there's one called SHARP, and then there's a couple on here that I hope we're going to get to as well, which are dbGaP, which are EGA rather than dbGaP. So what we hope we will be able to do is get to the point where we can merge through Data Connect and some of the other sources these data from these different sources. And so that in terms of, you know, getting to the kind of thing you were describing, Susan, is you know, along those lines. But specifically the mapping stuff. So this is one of those tables. This is the Childhood Asthma Management data set. And so this is the Data Connect schema that you get back from the API. And as a reminder, we didn't have to create this. This is translated from XML on the fly from a site that NCBI makes available. And what the Data Connect server running, well, this Data Connect server right here running on nowhere else than my laptop but it's a Docker container. Other people could run this. That Data Connect server is translating that XML data dictionary that dbGaP provides to JSON schema. And we can see, for example, that it says it gives us information that 1 is female and 1 is male and 2 is female, et cetera, and that 0 means unknown, and this is for asthma, right? Does this person have asthma? So what we did here, now if you run a query against that table in Data Connect, this is what you would get. You'll get a column that says asthma and a column that says current smoker, and it's coded according to those values up there. And one of the thing that I added yesterday, which was only a slight modification of some code that we did before, was to get what's called, I'm calling a decode template. So we run that and it'll bring back in this JSON the fact that we, well, basically don't focus on the JSON. It brings that back and we call that decode. And then to transform the table that I looked at before, this is, if you're a data scientist and you work with data frames in Python, which is what people do, people who call themselves data scientists do, I've been led to believe. And so I've gone and looked at kind of what they do. We can transform this to this. And so the 1s and the 2s get decoded to something more meaningful, which somebody can work with and sort of get on with some science with. So here's another query, which the query that this runs in Data Connect is against the same table. And it's summarizing, I mean, this is just giving counts of two, they've got 2 variables in, they've actually got more than 2 that are current smoker and ever smoker. And again, I don't know what 1 and 2 and 0 mean. And I wouldn't be able to do any useful analysis with that. But again, the next function, it says, I'm going to call this variable decode2. And that pulls back from that data connect schema what we're looking at, a mapping, which we can then go and use and apply to the data frame. So we've gone from this data frame to that data frame, where those are decoded kind of just like that. And so that's now done. My to-do is done, so I'm going to delete that. But the important point here is to illustrate the value of these machine readable data dictionaries. This data still isn't harmonized. And that's the ivory tower somewhere on a hill that we're trying to get to. But that even on itself did something useful. And you know, that was pretty easy to put together from what we already have in Data Connect. We just not, I guess it depends on your sport, right? But we've not put the ball in the back of the net, which is a fairly, there are lots of nets. That works for ice hockey, right? As well as, it's a puck, sorry, as well, rather than the ball. But so it's pretty international. Why did I pick this data set? What's useful here? All right, let's skip over that one. This is one we've looked at before. This is another of those asthma data sets. Well, it's actually the Childhood Asthma Management Program again. But this is a different data table. And we've looked at this one before. It has things in it like, what is the protocol? Well, that's sort of, yeah, within that study. But one of the things we found is, what is the treatment group? And the codings there are, 1 is albuterol, 2 is azithromycin, and so on. And we looked at this, and then I looked at it yesterday. You know, using that, we can do something with it. I can go using from that schema, I can create myself what I'm going to call a decode template. So what I then did was copied that and pasted it. And you can see I'm halfway through it. And what I was doing was, you know, I used my good friend, Google. And what I said, well, I know RX norm. There should be better tools than this, okay? But I can do it with a tool that's available to me. I said, what's the RX norm code? Because I know RX norm codes are the codes for drugs. So they're one of the codes systems we could use for drugs. And so I can go and say, and in from BioPortal, I can go and find out what the code is for budesonide. And here it is. And so I can just copy and paste. And this is, of course, this is a bit laborious. I can go through, and I'm halfway through manually creating my mapping. That will mean that this data is now mappable to a semantic standard. Now, I'm not suggesting that lots of, well, it depends. If this is useful to someone, we've enabled them to do it. Because they might be trying to merge this data set with a data set that was using these values. But then we've got, I've called it my decode, right? So that's going to decode this treatment group. I mean, and we might have liked that this data set, when it was created, they had used the codes for these drugs in there, but they didn't. But the point is, we can get onto the question, and again, we've looked at doing saved mappings in various ways. I think this is already running. So here's, as they say in a famous British TV program, one I prepared earlier. What I'm saying here, what it says, get mappings for variables. So what it's saying, get the mappings for this variable. Well, where is it? What am I using there? That's something that was in our schema here. So we've got treatment group, and then this is the variable number. So I just use that ID, that's the ID of the variable, and say, well, what have we mapped that to? What's available in a library of mappings? And I already have one that, Jonathan and I have mucked around with this for probably, some of this goes back a couple of years when we first created that table and made it available through the DNA stack implementation. That we can then say, okay, well, we've just got one mapping for that variable, and it would map the terms that they've used. It's a mapping of terms. It's map ID 1080, and it maps whatever had been used for that variable to CDISC race, which is a standard. So if we were mapping this to other data sets that were using the CDISC race standard, we can pull this one off the shelf out of our saved mappings, and we can use it in exactly the way I've just shown you to transform our data frame to be to do this. So looking at the example, this was how I created the saved mapping from the example that we've been looking at before. I just said add what I'm calling a JSON map. I'm going to give it an ID. I'm going to say it maps this variable. What does it map it to? This is just a funky name I came up with, and it's going to use that JSON string that I've created there. And then we can look and say, what are the mappings that we've got for that variable? And it will pull them out of the database and say, I can map your variable here. I've got two maps. This isn't very explanatory. I mean, this is just me mucking around yesterday, but those should have more meaningful names. And then once you've got a saved map, you can pull it out of the database, and you would use it in exactly this kind of way that I've been showing. And so we can get the current smoker decode, we can get the asthma decode, and we'll be able to use it in the way that I showed you before. Now, I mean, and here's another example. Okay, going back, let me, this one, okay, this comes way back up to the example that I showed you here. I think here it is. So this is this variable. Remember this number 493726 version 1. This was how they had coded case control status in this study. And a 0 meant unknown, a 1 was asthma case proband, a 2 was control. Well, say I was using that, and I'm talking about being a data scientist now. I'm using that where I'm looking at a bunch of other studies that have just said case control. But here, my case is coded in a different way. What it means is that I can go and create my custom mapping for that. I mean, and I've said, yeah, you know what? I want, that was how you mapped it. I want to take that variable 493726. And I just want to call one case. I don't want to call it what you'd call it. So for my purposes, so this was just illustrating that I think we've got things in the bank that we in Data Connect that we can show some value out of.